He is a PhD student in the Department of Geographical Sciences, University of Maryland, and he has some good background in applied economics, and he has been working with Dr. Bob Chambers and helping us with a total factor productivity calculations and risk characterization in nitrogen recommendations. So yeah, and with that, I would like to turn now to Xiangjie to present his work on nitrogen recommendation stuff.
Yeah,
The floor is
thank you.
yours.
Okay, thank you, Prasad. I'm very happy to have this chance to communicate our research with you. So for today, my topic is about the optimal nitrogen fertilizer use for the winter wheat on the price and the weather uncertainty. Yeah. First is a little background. First, for the farmers, they need to deal with the uncertainty, and the uncertainty mainly comes from two sources. The first is like the prices and also the weather. Yeah, these two sources of uncertainty will have impact on the yield and also impact on the return. But what is the role of nitrogen rate? Because different nitrogen rates will cause a different yield distribution under the weather uncertainty. That's why choose nitrogen rate is very important to deal with the risk. So once we have a prediction for the distribution on the yield and also the price, we can get a distribution of economic returns, and based on some decision criteria, we can get optimal nitrogen rate for the farmers. But the question is very obviously, but there is a research gap in past studies. The first, when past studies consider the risk source, in agronomy field, they usually consider fixed wheat price, or even didn't consider the price to get a nitrogen recommendation based on the maximizing yield. Yeah. Usually the agronomist usually just take the weather uncertainty into account, but the economist usually pay more attention to the price risk rather than the yield risk on the weather uncertainty. So there need a combination about both the weather and also the price uncertainty to decide our optimal nitrogen rate. And another problem is what is the decision criteria? The most commonly one in past studies is the expected return maximization. That means the farmer is risk neutral. They don't care how much risk they need to beer, and only consider maximizing their profit. But there are a lot of evidence that from economic students, they think they find that the farmers are risk averse. That means they actually will make a trade-off between the return and the risk. So in our research, our contribution would be we will consider the weather and the price uncertainty simultaneously and come up with the optimal nitrogen rates for producer that they may with different risk preference based on some risk decision theory. Here is our method about the data source. Yeah, we have the data for two experiment sites that are located in Oklahoma, Reno, and Ashland in Kansas. Yeah, we use the EPIC model to simulate the yield distribution on the different nitrogen rates and on the weather uncertainty. Yeah, we generate a weather ensemble from some weather database, and also have the soil data from soil database. these two databases will be used as input to the EPIC model and get a simulation for the yield distribution on the different nitrogen rates. And then our model, our EPIC model is calibrated using the data from the field size, from the experiment. Yeah. And the next step is to get the price and the yield distribution. Yeah, the price distribution, we get our, we predict the price behavior based on the historical data using econometric model that is autoregressive moving average model. And also we get an estimation on the yield distribution for including 4 parameters, that is the mean of yield, standard deviation of yield, skewness of yield, and the courtesies of yield. The reason why we also consider the skewness and the courtesies is a lot of literature shows that the yield distribution may be non-normal distribution. So we need to take this skewness and the courtesies into consideration. And then once we have the price distribution and the yield distribution, we can get the return distribution by a simple formula. Like the return R is equal to the revenue from selling wheat weight, that is the price of wheat multiplied by the yield of wheat, and deduct the cost especially the nitrogen rate is N, and also the price of nitrogen fertilizer. The price of the nitrogen fertilizer is fixed in our model because the farmer should be already know what is the price for nitrogen fertilizer when he apply it. Yeah, and also we assume there is a fixed cost for fixed management cost and other kind of cost for other things. And for the decision criteria, we can consider 2 models. The first is risk decision model, that is the constant absolute risk versus expected utility model. Yeah, our goal is to maximize farmers' utility, and the utility function is set as exponential utility form. Yeah, that is very commonly used in risk analysis. In the equation, the B is a coefficient of constant absolute risk aversion that reflects the farmer's opinion on the risk and the return. If a farmer is very risk averse, then he will have a high value for the B. Our criteria would be maximize the expected utility. And when B equal to 0, actually is equal to, that means the farmer is risk neutral, and the farmer will choose a nitrogen rate to maximize the expected return. Yeah, that is used in most of past studies. And another model we can see there is the invariant preference generalized deviation model, that in briefly the IPGD model. In the IPGD model, the key idea for this is farmer prefer upside deviation to downside deviation. If the revenue distribution is a normal distribution, then actually the result for IPGD model would be the same for the expected utility model. But once the distribution of return is not a normal distribution, then the result from IPGD model would be very different from the expected utility model. In the IPGD model, actually have similar ideas, like the A is similar with the B in the utility model, and capture the attitude of farmers toward the risk, and the expected return is not the return is not the mean of the total sample, but the conditional mean of return falling below the mean return, and the R is a risk measure that is the normal semi deviation of return. So in the IPGD model, we will maximize this criterion function to find the optimal nitrogen rate. Yeah, here is the result for our yield and price distribution. For the price distribution, actually, like the orange area is our predicted price distribution at a 90% confidence interval. And we can see most of the years, our prediction, the real price would fall into our confidence interval. Yeah, so I think that this model, the ARMA model, is good to fit the price. And also we can see the distribution of yield. And the corridors is our field is our simulation result from EPIC model, and the blank line is the mean of yield. The mean of yield first as the nitrogen rate grows, the mean of yield would also be grows until it achieve a yield saturation point. And the same as the similar is happened to the standard deviation. And when we look at the skewness and also the courtesies of the yield, we can see there will be a positive skewness, the red line, in our cases. But this is not definitely true for all of places. When we check the literature, they find in some places the skewness may be positive, but in other cases it may be negative. But at least in our data for Reno and Ashland is positive, and for the courtesies is much lower than 3. That means it's much lower than normal distribution. So the skewness and the courtesies in here shows that we cannot just predict. We cannot predict the yield distribution just with the normal distribution assumption. We need to consider a non-normal distribution. And then combined with the price distribution and the yield distribution, we can get a return distribution. Yeah, like this, the origin area is also shows a confidence interval at 90% level. And the blank line shows the expected return on the each nitrogen rate or the mean of return, and the red line is the standard deviation of return. The green line is a conditional mean that below the expected return, and the purple line is the semi-deviation. We can see that with the increase of nitrogen rate, the return will first go higher and then go down. The reason is when it passes some point, this top point, past some point, the cost of the increase of nitrogen cost would bigger than the increase of return caused by a higher yield. And even when it reach yield saturation, the yield would not grow further, but the cost of nitrogen would go further higher. So it is inverted yield curve trend. And also a similar pattern for the standard deviation. What actually for the farmer, what they choose is actually choose a combination between the risk and also the return. Yeah. Like in the utility function, they will choose a point nitrogen rate. That means that would bring a certain return and also certain risk measured by standard deviation. Yeah, here is a figure that shows the trade-off, risk-return trade-off. I mean, the x-axis is the risk measure. Maybe it can be the standard deviation of return or the semi-deviation. And y-axis is the expected return. Actually, the farmer have to choose a point to that is suitable for the internal risk appetite. And each point actually is corresponding to a certain nitrogen rate. we can decide the optimal choice based on the criteria function and also the expected utility function that I mentioned before. And finally, we are going to get optimal nitrogen rate for farmers with different appetite, different risk appetite. The top figure is the result for expected utility model, and the bottom one is the IPGD model. Like in the expected utility model for risk neutral producer, that is the black line, the optimal nitrogen rate is between 60 to 80 kilogram per hectare for ashland, and 100 to 140 kilograms per hectare for Reno. And in IPGD model is much lower. Yeah, for different years in ashland, the optimal rate is 15 to 55, and in Reno it's between 30 to 19. The reason is in our cases is the yield distribution has a positive scalars. That means the curve of conditional mean that below expected return, the green one would have earlier, like in the have earlier top point for the compared with the total expected return. So in our case, in the IPGD model, the optimal nitrogen rate was lower than the expected utility model. And if there is, in some cases, that there is a negative scalars of yield, the situation would be in contrast. The IPGD model will have a higher nitrogen rate than the expected utility model. Compared with the real practice in the area, we have the state level average nitrogen rate from USDA that for Kansas is close in 2019 is close to 86 kilogram per hectare, and in Oklahoma is 80 kilogram per hectare. Yeah, it's close for Kansas is close in the expected utility model is close to the risk neutral producer, and for the average practice in Oklahoma is actually maybe close to the risk, close to the choice of farmer with a risk coefficient about 0.3. And then I also calculated the return and the risk under the optimal nitrogen rate. The return is the expected return. The risk is the standard deviation measured by standard deviation, and these numbers is calculated by the outcome under the return and the risk outcome under the optimal nitrogen rate. Yeah, we can see actually the risk-averse farmer is be able to reduce the risk significantly just with a small expected return losses. That, for example, for ashland, just for the very risk-averse farmer, that B equal to 0.004, only have face loss of expected return about $5 per hectare, but its risk will reduce from 167 to 152. So in our case, the risk averse behavior is we don't bring much opportunity cost. But this is depend on the case. In our case, maybe is depend on two aspects. The first is the relative price of nitrogen fertilizer to the wheat. If there is a very high relative price of nitrogen fertilizer, that means a reduction of nitrogen fertilizer will save a lot of fertilizer cost. Yeah. And also, it also depends on the slope of expected yield response to the nitrogen rate. That means a lower slope of the yield response to nitrogen rate. That means when we reduce the nitrogen rate, we will not cause a lot of cause a lot of decrease in yield. Yeah. That's basically what we do for now. We are working on a paper, about this. But yeah, but actually we still found something to improve, especially in the yield distribution. Yield distribution estimation. Yeah, we now use a quadratic plateau model to feed our model. Actually, 4 model. Separately for mean, standard deviation, skewness, and curls. We are trying to find a way to estimate find a way to estimate all of these parameters in just one regression. There potentially solution is the I remember is the maximize likelihood method. We are trying to improve this part now. Yeah, and that's all. And I'm looking for